and welcome to today's webinar on robotics. Now I request Mr. Parthiban, Assistant Professor, Mechanical Engineering, to welcome and introduce a resource person.
Thank you, Mr. Niranjan, sir. I wholeheartedly welcome all the participants for this wonderful webinar on robotics. It is a pleasure to welcome everyone to our beautiful venue at this present moment. We would like to extend a special welcome to our guest of honor, Mr. E. Venugopal, Assistant Professor, Department of Electronics and Communication Engineering from
from
Sri
Sri
Ishwar College of
Ishwar
Engineering,
College of Engineering.
Coimbatore. He is our former student of King's College of Engineering and he completed his BEEE in 2006. Next, he joined in GCT Coimbatore for studying power electronics and drives for his master degree. And he has a vast 11 years experience in teaching and project guiding in accumulation of both King's and Ishwar College. I'd like to
I like to extend.
explain his roles and responsibilities. One is he is a IEEE students branch counselor, and the other one of the project coordinator in SECE, and next robotics and RC club coordinator for the EC department, and the next one member in IEEE Robotics and Automation Society and in ISTE. Next, about his achievements in guiding the students project in higher level competitions. He has won the third prize for the project contest in Elekrama 2016 by Government of India and final contestant for the International 2018, the semi-final contestant in Smart India Hackathon 2019, and final contestant for the International 2019, project selected in Smart India Hackathon 2020 for the hardware edition from the Ministry of Uttarakhand for unique design of UAV. And the most important work he has done is he submitted one patent in power generation and two patent drafting is in progression. So I wholeheartedly welcome Mr. Venugopal sir to proceed this webinar on robotics. And thank you. And I give the session to our resource person, Mr. Venugopal sir. Sir, please, sir.
Yes, sir. Thank you for the introduction, sir. Am I visible, sir?
Yes, sir.
Yes. It's my great pleasure to give the webinar to my college. Thank you. One thing I have to tell you, I personally thank the management of King's College of Engineering and thank our Honorable Principal Madam, Dr. Arpuda Vijay Selvi Madam, and beloved Vice Principal Sir, Dr. Shivakumar Sir, and the HODs of various departments, EEE, EC, Mechanical, CSE. I thank each and every faculty members in King's College of Engineering for giving this opportunity to deliver this robotic webinar in webinar manner. Right, I thank you. Now we start the section. At this section, this webinar section is not like a theory part. I think we have the content that is the outcome of this course, which is nowadays the robotics, which gives a passion manner. That's in a sports manner or doing a line follow robot like this. But this section would helps you. It has a career-based opportunity in robotic platform. Right now, I'll share my screen. Okay. Sir, is it visible, sir?
Sir, change to presentation mode, sir.
Share my meeting window.
Yes,
Yeah,
sir.
sir, it's visible.
It's visible.
So is my screen is visible?
Yes, sir.
So now, sir, is it visible?
Sir.
Niranjan, sir, is it visible?
It's visible.
Right. Thank you, sir. தமிழுக்கு முதல் வணக்கம். And I'm Venugopal, working as assistant professor in Sri Ishwar College of Engineering, Coimbatore. And today's section is the webinar on robotics. And myself, Dr. Ganesh Kumar sir from a mechanical department, he's one of the robotic club coordinator, is going to join with you. The objective of this workshop, you would get an information about the robotics, types of robots, and then how to get started in robotics. This is the basic factor where we start the robotics. But everybody interested in doing some robotic based process like RC car, drone, flight, but they are struggling in how to start the process. So we will give you the starting process in how to do your basic robots and what are the platforms will help you to do a robot. And then online platform to develop robotic knowledge. And the later careers in the field of robotics. Nobody knows about them. This robotic will have a very good vast field in the future. And then essential skills needed for a roboticist. Yes, Mr. Vasu, please turn off your mic. Yes, Mr. Vasu, please turn off your mic, then only I can proceed, right? And then essential skills needed for robotics, and then you need a passion to do. That's the main key factor to do a robotic platform, right? Let's do engineering rather than studying engineering, right? Right. Robotics. So robotics is a branch of technology that deals with the design, construction, and operation and application of robots. And then it has the combination of 4 streams, that is electronics, then computer science, mathematics, and then mechanics. These 4 systems which combines the robotics. So if you are unique in any one of the engineering stream, you should know the other streams. Then only it should be a good team. Then robot. Here comes the robot. Robot is a machine which has performed a certain task automatically to achieve a system. And then here it comes the types of robots. There are 15 types of robots. This segregation is based upon the application wise, like industrial, defense, medical, then humanoid, underwater, exoskeleton, aerospace, drones, consumer, disaster, research, education, entertainment, and then telepresence, self-driving mechanism. Let's see the individual types. The first is the industrial robots. So the industrial robots is specifically for arm-based robots, which is used for many car industries, and it has designed to perform a repetitive task. right? It will be programmed by giving a learning mechanism. We have to teach the robot how to do a project or how to do a job. Then it will learn something from us, and then it will do the task repetitively. And then for the defense, it's used for improvised explosive devices, and it may be used to assist troops in carrying heavy gears in defense system. The third is medical, and this is a very vital in terms of robotics. For example, the Da Vinci surgical robot. This can be operated from a remote location. Either it may be in China or it may be in US. You can directly operate that robot from a remote location. And the humanoid. As you think of a robot, you think that it is like a human robot, right? So here comes the humanoid robot, which is a mechanical appearance or designed to look like a people. It should have artificial intelligence, machine learning, deep learning, and everything. And then underwater robotics. And these robots, nowadays, these robots play a vital role to searching objects in underwater. It has an LiDAR technology or ultrasonic sensor in underwater for geographical mapping. And it may be with or without an operator. Either it can be an autonomous vehicle or it may be operated by an user. And then exoskeletons. These robots, which is used for physical rehabilitation for a person to walk, and then it is used in a military and industrial purpose to lift heavy loads. And then in aerospace, all sort of flying robots. Example, gliders, UAVs, or in military they have to utilize a vehicle, weapons mechanism. And then here comes the drones. As we already known about the drones, which plays a vital role, and in some application they move the carrier-based object, that is moving cargo, then moving some courier-based applications. Then nowadays drones are used in agriculture also. And then it has a different sizes based upon the anatomy, that is quadcopter, tricopter, octocopter, hexacopter. Based upon the application and payload mechanism, they have to increase the number of propellers in that wing. And then for the consumer, the Rombo vacuum cleaner and several toys comes under this consumer robotics, right? You can buy and use. It should be a toy-like appearance. And then for the disaster response, and these robots perform dangerous jobs like searching for a survivor in the aftermath of an emergency, right? And then for the research, this plays a vital role. For any research, it will help to increase the anatomy of an new unmanned aerial vehicle or a new robotic process. It will help you a lot. And then for the education, may be used by the users. For example, this Lego robots, which comes under the STEM Foundation of India, which leads so many projects based for the school students, right? For the education purpose. And for the entertainment. And these robots, like a dog, they are designed to evoke an emotional response. Can be made as a fun-based activity entertainment robot, maybe a PLC-based, that is a company called Mitsubishi or an Fanuc. These companies which are leading in manufacturing industrial robot for there's a car manufacturing industry, but they are interested to do table tennis, ping pong ball-based robots. And then telepresence. So it allows you to present at place without any actually going there. So it's from the remote location. You have to tell the robot to do some objects in somewhere in the world. And then the last one is a self-driving car. It is an autonomous vehicle. Already launched Japanese. And then here comes the Boston Dynamics, the leading robotic manufacturing industries. And then how to get started in robotics. So it has 3 levels. The level 1, just getting started with microsystems. So the microsystem in the sense, either you can use a Arduino controller or a MSP430 or any small controller devices which can perform a task for a simplified application. And then in the starting stage, you must learn to program, how to program an Arduino, how to use an Arduino. In the later section, Professor Ganesh Kumar sir will tell about how to use the Arduino and in online platform, right? And build the robot using basic hand and power tools. This is the basic rule. If you are a well-wisher, you must do your robot in your hand. It will teach you a lot. And then you must join in a robotic club. If you are in a team, it teaches a lot. If you are in a single alone person, you're doing a project in a alone, it produces much disturbances, and the time is very long to complete a task, right? If you are in a team, it will teach a lot, and you can get more information with short timings. And in the level 2, with an embedded computing. In the previous level, you may use Arduino board or MSP430 or CC Link or something, which is a miniature one. Here comes the advanced level. Maybe you can use a microprocessor-based computing system. You can set a clear and realistic goal. So in order to design anything, you must fix what type of robot, what type of wheel mechanism, or what type of propellers, what type of design, you must realize. Then it should be a good thing to make a product. Right. In level 2, you may use advanced control board like Raspberry Pi, and you must know how to program with Raspberry Pi like a Python, Linux, or connecting sensors and motors to the microprocessor or computer on a chip. And then design your parts with the CAD tool. This will be very important. You must stick on to, if you are an electronic engineer, you think that I'm an electronic engineer, I won't need any mechanical or not like that. If you select this field, robotic field, you must learn all the fields. Then only you can recognize your product should be a pakka one, right? So design your parts with the CAD tool. And then new material and construction technique like 3D printing, laser printing, you must use this type of construction. You can build your own design models. And then make your robot act as desired. What do you think in the first level? You must stick to the plan, you must design as it is desired. And in the third level, it's an advanced computing. So here also you have to set the clear and realistic roles, what to do and how to do the projects. In the second, the very basic is max. Why we need the maxes? You must understand the design consideration and project-based learning. So you must go to the statistics and trigonometry is very basic for doing a robotic application. So if you have to try any new model or new design, you must go through the basics. So that's need a basics of maths, physics, and also if you use some chemical mechanism, you need a chemistry background. And then in this advanced computing, you don't need to design, but you may shop under as it is machined, right? Because if you have to design each and every part, it will be a waste of time. So for advanced computing, you may use the buy products, right? Like a LiDAR camera or a thermal imaging camera, you have to buy that type of sensors. Here comes the how to learn and use more advanced sensors like a LiDAR sensor, like in Agni 6 missile of India. They use as ring laser gyroscopes. Like we have to search for advanced sensors. And then the important thing is ROS. You have to learn the robotic operating system, ROS. In the previous year, the Kinetic robotic operating system, Kinetic Turtleboard 2 was used. Here, from this year to 2023, the Melody version of robotic ROS 1 will plays a vital role. If you are a good roboticist, you must learn ROS. After Python and everything, you must learn the ROS, right? In order to learn the ROS, you must learn the Ubuntu. You have to install the Ubuntu, then only it will help you a lot. At last, the algorithms. It's a key factor, and tomorrow's world based upon this algorithm and learnings. The algorithm, which is artificial intelligence, either it may be a physiologic neural network or a genetic algorithm. And in the learnings, you have to teach your robot. The robot can learn from you. So you have that learning in the sense normal programming, and then machine learning, deep learning, everything comes under this. And in the later part will be described by our professor. Sam, may I ask Dr. S. Ganesh Kumar to deliver this work?
Sir, good morning. Am I audible? Am I audible,
Yes,
sir?
sir.
Good morning.
It's
Yes, sir.
audible, sir.
Good morning, sir.
Good morning. Good morning, sir.
Morning, sir.
First of all, I would like to thank Dr. J. Arpuda Vijayaselvi, Madam Principal, and Dr. P.P. Santaraman, sir, and Professor Niranjan and Professor Pasupati, and all other organizing team for giving this excellent opportunity to take this session. First of all, I would like to thank you all. Sir, PPT. Today, in this session, we are going to see how to simulate a Arduino in the platform Tinkercad. We will do, and I will give you a DIY manual. It is called as Do It Yourself manual. So, please wait. I'm going to share my screen. Okay, the pen drive. The DIY manual. PDF. Or Okay, sir. I will take. Thank you. Is my screen is visible, dear students? Is my screen is visible?
Yes, sir.
Okay. Okay, sir. Thank you. And this is one manual. Here I gave a DIY. Full form is do it yourself with all instructions. In this session, I am going to tell you how to simulate Arduino program by means of a code block or in a CNC or in the C format. From this, we are going to see how to simulate Arduino using the software Tinkercad. It is an online tool. From this tool, you can simulate. I will give this 10 exercise, okay, for the practice purpose. From this, you have a here you have a first exercise. It is the basics of Arduino. You have a pin connections and all. Here you are having pins for input and here you are having pins for output. We have A0, A1, A2, A3, A4, A5. These pins are called as analog input pins. And here you are having output pins. It is 0, 1, 2, 3, 4, 5 up to 13. And this G and D means of a ground. It is called ground. Then from this board, you can able to extract 5 volt and 3.3 volt of power supply.
Hello, excuse me,
So this is
sir.
a provision. Yeah, yes, sir, please.
Your PPT is not visible, sir.
Oh, okay, sir. Sir, PPT. Sir, is my screen is visible? Okay, okay. Sir, abhi screen share பண்ணிடுங்க. Screen அப்படியே screen share பண்ண முடியாதா? இந்த PPT ஓபன் பண்ணா கூட ஓகே. ஸ்கிரீனையும் ஷேர் பண்ணும்போது அந்த வெப்சைட் லிங்க்கும் வந்துடும். ஸ்கிரீன். Sir, now is it visible? So, sir, now my screen is visible, sir.
Yes,
Is
sir.
my screen visible? Okay, sir. Thank you very much. Visible. So now, can you see one Arduino board here in your screen? So now, can you see one Arduino board?
Yes, sir. Yes, sir.
Okay, sir. Thank
Oh,
you.
yes.
Okay. So this is the board, and here you're having 6 input pins. It is A0, A1, A2, A3, A4, and A5. These pins are called as analog input pins. And here you're having output pins. It is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So okay, up to 13 pins you're having. It is used to take outputs from this board. Then here we're having GND. GND means ground, and here we're having 5 volt and 3.3 volt provisions to take power from this Arduino. So now we are going to see how to program Arduino using the software Tinkercad. And this is the basics of electronic components. It is LED, photoresistor, and a stepper motor, servo motor, next is breadboard, 7-segment display. So these are all the basics. And this is the software which is used to load the program in Arduino. It is taken from the website Arduino. So it is a software which is offered by the company Arduino itself. So this is a software. So now I will give you the link of this software. Now this is a pin connection. We are going to give pin. So it is a connection we are going to give with the computer to give the program to the Arduino. This is a cable. It's a cable we are going to use, and this is USB B type and other A types. And next is so now it is the first exercise we are going to use. It is a platform we are using to program Arduino. If you are using the Arduino to program in real time, then we will use this software. So now we are going to see simulation directly. So it's the basics of robot, as our Professor Venugopal sir already told. So now we are going to start from here. This is step 1. This is the screenshot of the platform Tinkercad. Now, so now the first step is go to the website Tinkercad. This is the first step. And next step is you have to log in. First, you have to sign in with your Gmail account. So with your Gmail account or your Facebook account. The next is step 3. We have the platform like this. So now I will show you the platform clearly. So now there's a platform. You can do the circuit connections. You can simulate the Arduino, and you can send the program to the board Arduino using this software. You can simulate your programs. You can check your programs. And this is step 4. simply you can drag. We have a pick and drag option only. So here you can drag the Arduino and keep your so now you have to fix your components in this platform. Then the next step is you can pick some other components like LED, photoresistor, thermal resistor, etc. So now in this exercise, I am going to drag one LED. Then you can drag and fix the LED here as shown in figure. The next is you can connect the cathode terminal to the ground and anode terminal to the pin 8. I'm showing here pin 8. Now I will show you the demo later. First we will see here. Then next, if you are going to do these connections, then we have to program this Arduino to make blink. So now this exercise is going to tell how to perform the Arduino to make blink this LED. So it is our program. Now we are going to give programs to this Arduino. Now we are going to give this toggle code editor. It is called toggle code editor. In this toggle code editor, you can edit or you can give programs in means of code block. So it is called as code block editor. It is also called as code block editor. Now you can drag as we did already to drag the photoresistor and to drag the Arduino into a platform. Similarly, you can drag this code blocks and you can fix here and you can program here. Then next is you can simulate. This is the steps we are going to use in Tinkercad. So this is the first exercise. So now I am going to show you one demo. It is simple. It is very simple. So now this Tinkercad website. So now I told you, go to Google and go to Tinkercad. Tinkercad is the website we are going to see here. This is the Tinkercad website. Now this is a Tinkercad, the website we are going to use for simulation. www.tinkercad.com. Please note down the website. Tinkercad.com. This is very much helpful to learn Arduino, and you can simulate this Arduino programs, and you can do your own robots. You can place robot and other robots. You can do your own. And in this session, we are going to simulate lively. So because we are going to see lovely, so lovely manner. Now sign in. Go to sign in here. Now sign in. So please write Google. Now I'm having already my account. Then I'm having already my Gmail account here. Then you have to enter with your Gmail account, or else you have to sign up. It is free. You have to sign up and enter into this website, tinkercad.com, and this right system going to enter. Then the platform. The next is 3D designs, code blocks, and all. You have to use this module. First, I will tell you the circuit. Then later, I will do 3D designs for circuit and circuit. This is the second step. First, enter into Tinkercad. Then you have to sign in. Then go to 3D circuits. Then you have to create a new circuits. This is the third step. Now you can able to see the like Arduino, photoresistor, and other things. Please, you can see here this is available. Now we have a LED, we have a resistor, push buttons, and potentiometer, capacitor, slide switch. The next is we have a battery also. We have a battery, an Arduino. The next is we have a motor, servo, stepper, DC. The next is rear body motor, resistor. All other components are listed here. First our basic components is Arduino. We have to pick one Arduino. Then simply drag here. Drag. There's a pick and there is a pick and place option here. Use this use your mouse and click system is slow. Then you have to drag here. Then place this Arduino here. So now it is available. As I told, our pins A0, A1, A2, A3, A4, A5 here. Then next is we have to give connections for this Arduino. As I told, we have to drag one LED. For this basic simulation, I'm going to drag one LED. We have LED here. Now I'm going to give connections for this LED. I'm going to give, see, this is a cathode. This cathode should be connected to the ground. So I gave connection to this cathode. Okay. Now we can give this anode to any, see this pins. This pins is called as output pins. As I told already, 0, 1, 2, 3, 4, 5, 6, 7, 8, up to 13 pins, you can get output. This is called output pins. You are going to give the connection to any pin. So now, say for example, I am giving to pin number 9, then it is given here. Then you have to change color. There is a signal for this, see this for this LED. Next is ground is given as a black color. It's a default color. As you know, this color is default. Then next is you are going to program. Now we attached a circuit. See this LED and all other things. We have to program. Now go to toggle editor. As I told you, this toggle editor. Go to toggle editor. We have already some commands and code blocks. Okay. So now you may, right. So now you are going to delete this codes. Delete this codes, and you have to set pins. So now I am going to make this LED blink. So it is my aim. Okay. Now I'm going to give the set pin 0 high and other things. No. Now you're going to set pin. Take this code block. This is also used to other. So now this code block is used to rotate a servo or speakers and other things. We are going to use this code block to make this LED blinking. Now we are going to control this. Controlling. So now take weight and Samuel sir, am I audible? Sir, am I audible, sir? Hello? Hello? Sir, am I audible? Hello?
A bit, sir.
Oh, okay,
Yeah.
okay, okay. Okay, okay, sir, thank you. Now we are going to use this output, then this same set pin to high, low. This is a command block, this is a code block I'm going to use. Then I'm going to attach this code block to this area. Okay, now it is available here. Now I attach to pin number 9. It is pin number 9. So I have to give pin number 9. Then similarly, I'm giving with the same pin because this is only on single pin I'm going to use. Then high and low means it is 0 and 1. It is called as on and off, high and low. Then it has to wait for 1 second. I gave 1 second. So I gave the code blocks here. Then I gave the circuit connections also here clearly. Then I'm going to switch off this blocks. This course is off here. Now we are going to simulate. So now the circuit is ready for simulation. Now go to start command. Then you initialize this board to simulate. Now it is simulating. It's going to wait for 1 second. It is 0 and 1. Please wait. Now high and low set pin. Wait for 1 second. Yes, it is starting. It's going to wait for 1 second and on and off. Since the system is slow, you have some delay, but it is working. Okay, and now the circuit is going to make this LED blink for 1 second and is going to wait for 1 second on and off for 1 second with this sequence. So this is the purpose of this software online platform to simulate the Arduino. Okay, you may use a servo motor, stepper motor, or it may be a photoresistor or a speaker, or it may be DC motor, or whatever it may be, you may use and you may simulate with this platform. I hope you understood. And is there any doubt? And is this session is useful? Is there any doubt, or is the software is useful to simulate? Hello, excuse me, sir. Okay, no problem. There is no answer. Okay, now we have the components like photoresistor, ultrasonic sensors, distance sensor, etc. Simply, it is like a game. Simply, you may give this Arduino and other components, and now I am going to delete this. Simply use the delete command in your keyboard. Then you can delete this. It's like a games. It's like a video games like your PUBG and all. You can play like this. Then you may learn in a funny way. So it is a purpose of this Tinkercad platform. And next, we can rotate this components also. This is simply, it is a 9-volt battery. In a real time, you have to give a resistor. For simulation purpose, I'm not giving here. Now, I told you this cathode should be given to the ground. Okay. Now that is given to the ground. And again, you're going to give this positive to anode. Here, what happens? I'm not having any Arduino or other things. Simply, I'm using a LED and a simple, it is a battery. Now, I'm going to start simulation. It is working. So, it's a basic simulation. You can do your own in a funny way, and you can learn this robotics in a funny way. Okay, now I'm going to do some other cases like as I gave in our DIY manual. This is a servo motor. I'm going to use, it is also a simple way. Now I'm going to use this servo motor. Then I'm going to use a battery. This servo motor plays a vital role in the pick and place robots. If you're going to design a pick and place robot, the servo motor plays a vital role. You're going to use 2 or 3 motors to make the robot move. Okay. Now I'm going to use a robotic. This is this platform Arduino controller. Pick and drag this Arduino. Drag this Arduino here. Now that is here. Yes, we will see pin configuration of this servo. This is a servo motor. Servo motor has 3 pins. We have a signal, power, and ground. We have 3 pins. In this ground, you can attach a ground. See here. You can rotate, as I told, you can rotate those components in clockwise or anti-clockwise direction, like this. Then you can drag this. Okay, now you can give the pins. This is a signal, this is a ground, and this is power. You have to give power from this Arduino itself. We have a 5-volt power supply. Okay, 5-volt power supply is given to this Arduino here. I am going to give this 5-volt power supply to this power pins. Now it is given. Now the second step is you have to give the ground. Ground is here. You can give here. You can give this ground to here, or you may attach with these grounds, because these grounds all are common. Now we are going to give the signal. Signal is an input. We are going to give the input. That input is taken from these pins, because signal is fed from the Arduino. We are going to send the signal from the Arduino. So it means what? It is an output. It's an output from the Arduino. I'm going to give a pin number 8. Say for example, I'm taking pin number 8, or else you may take any other pins. Here I'm going to take pin number 8. Pin number 8 is given. Now you can drag this. It's called wiring. Use proper wiring to avoid confusions. Here you're having only 3 wires, so there is no confusion. If you use more wires, then will give some confusion. So please use color codings. Now the signal give always in orange color. This here. Now can change the color also. So slow. So, okay. Now we are going to get programs for this servo motor. Now, as usual, I'm going to go with code editor, so code block or toggle editor, and I'm going to use this command of input the next MAC variable notation. Now I'm going to take the pins. It is the pin numbers, other things. Now I'm going to use this servo, because we have a separate block for servo. I'm going to use this control block. It is a weight. Then you can repeat the same with the same operation also. And then simply drag. There's a pick and place option. Then you can use the rotate servo option here. Then go to this. Then you may attach. As usual, as I told, since it is it's a simple step, I'm going to use this single servo. If you're going to use 2 or 3 servo, then you have to use the pin number 8, 9, 10 and other things. You have to use separate pins. Now I'm going to take the pin number 8 because I took the pin number 8 in the board. So I'm going to give the program 8. 8 is given. Similarly, 8, having 8 here. Then I'm going to make rotation of servo of angle 90 degree. Say for example, I'm giving 90 degree. Then now this program is ready. This is called as code block type editor. Now I'm going to start simulation. Now switch off this toggle editor. Then you can use simulation tool. Now it is running. So it is a steps. It is a steps used to simulate. Now you can change the angle also. You can change the angle. You may use speakers. You may use motors. Whatever it may be. Then you may use this. Then simulate the step. So in the final session, the see, I will give you. I'm having a file. It's not here. PDF. I will show you the PDF. Then I will share my PDF to your email. Then you have to do the program. You have to do the program for 10 exercises. Then it's easy to understand. Okay. Now I'm going to move to another topic, which I want to tell you. It is, as our SAR told, this Arduino is one of the tool to simulate or to actuate the motors like servo motors and to actuate the LEDs and other things. This is a part of a robot. Now we are going to see some other components of robot. It is called as 3D printed parts and other parts we are going to see. It is for this you have to do the 3D printing, or else you have to design and you have to model this. For this you can use one website. It is Thinkiverse. Thinkiverse. It is a website. It is a very interesting website. Go to Thinkiverse. In our previous case, we saw the website Tinkercad. So from this session, I'm going to tell you 4 important websites. So please don't forget this. This Thinkiverse. Go to thinkiverse.com. Then the website is like this. Please make a note. First is Tinkercad. Second is Thinkiverse. Then next is go to Thinkiverse. This website has a gallery. You can download the 3D printed parts. It's a 3D model you can download. I'm having my ID. Go to sign up. It is free. I'm going to log in because I'm having my ID. You can log in using your Gmail account itself. Now I'm going to enter into this Thinkiverse. Now we will see what happens. This is now I entered into the website Thinkiverse. Now we have a gallery of 3D models. Okay. Now I'm having the gallery here. Now you can download the 3D models in form of STL file. Full form is stereolithography. This file is used to make 3D printing objects. You can search for any objects. Say, for example, I'm going to search for a pick and place robot. Means I have an option pick and place robots. Then I'm going to download the pick and place robot 3D files. Okay, now see here, this is it is a gallery I received from the website. We have see, it is a 3D models which is already available. You no need to draw, you no need to create a model using CATIA or Creo Elements and other softwares. It is already developed, it is already designed and modeled. Simply you can download and make 3D printing objects. Then you may attach the servo motor or gripper or whatever may be. So it is a first step. For beginner, it is very easy. If you're familiar with this Arduino and this 3D printing, then you may develop your own 3D printer models. And these are 3D printer models. If you go inside this gallery, then you can download in format of STL. Full form is stereolithographic format, as I told you already. Now you can attach these parts to the servo motor, stepper motor, Arduino. They have all provisions to fix the Arduino, to fix a stepper, and to give the circuit connections also. This is a simple pick and place robot. As I told the software Tinkercad, we have a servo motor here. You can attach a servo motor. Before that, you have to simulate the servo motor in a Tinkercad platform. Then you have a good confidence in programming. Okay. Then after that, you may enter into the real-time process. Okay. Now I'm going to download this. Then you can give the 3D printing of these objects. If it is available, then you may give. They gave the parts here. It is the photos of the parts here. Here in this website, they told the parts like this. It is available. You have to download this parts separately. We have a 6 parts is available. You have to download this 6 parts and you may give print and you may attach. The next is, sir, please, sir, yes, what am I panna? Hello? Oh, yeah, it is running. So now we are going to see another one website. So please make a note, ThinkIOS and Tinkercad.com. So please don't forget this. It is very useful for simulation of Arduino. If you are familiar with this Tinkercad, then you can build your own robot very easily. It's in a pick and place, or it may be an obstacle avoiding robot. You may give your own robot in a very simple manner, easy manner. Now I am going to tell you another one website. It is Instructables. Instructables. Okay, Instructables. Go to Instructables. Here, simply in this session, I'm not going to take the robots and pick and place robots and other things. I'm teaching you how to make a robot. How to make a robot, then how to do your own robots. Simply, I'm going to say the steps. Okay. Now it is Instructables. Go to Instructables.com. This is one important website. You can do a lot of projects in Arduino. You can do a lot of projects in this pick and place robot from basic level to higher level. Okay. I'm going to search pick and place robot. Pick and place robot is the first project. We are going to do pick and place project. Sorry, robots, no? Robots. Then they will give the steps. They will give the steps, including the programs, including the 3D models, everything. They will give a step-by-step procedure. Now, if you are familiar in building your own robots, then you can upload your project in this Instructables. Okay, you can publish your name. Okay, now this is one project. This is Arduino based pick and place robot. Now you can download the files as I told in ThinkIOS. In ThinkIOS, they will give only the 3D models. In this here in this site, they give all the steps, including program. Including program, they will give all the steps, step-by-step procedure with the clear photographs. See here, steps 1. It is a step 1. It is called DIY. Full form is do it yourself. It is a concept came from America. It is step 1 is Arduino shield, nylon, blind washers, etc. So and so, servo, motor driver, Arduino, everything they gave. Then step 2 is GUI. GUI means graphical, it is called a GUI means graphical interface. Then you can download this. Then next is GRBL controller, everything. You can draw, simply you can download the parts, you can download the softwares also. Here, GRBL is used to make the Arduino move in a specific coordinates, X and Y, Z coordinates. You can move. Then it is a code they gave. You can copy the code, step-by-step procedure they are giving. Okay. Now we are going to copy the code and you can use in our project. Design and print all objects in a plywood sheet. They have a designs. They have a designs. You can download and you can print in a plywood and you may cut. If you're having a laser cutter, then it is better. Then it is a program. Don't bother about program. It is available. It's already available in internet. But please, you have to know where to edit and where to change. You have to know where to edit. This is very important. If you know, then it is too good. Okay. Now you can download this. Then you may use this. Then you may use in your project. Then you may run. This is a website. You can download and you can search for any projects when you will be on your PG or okay. Simply you can download this codes and softwares, and you may use in your final year projects and other things. Okay, this is one website. Then next, I would like to say another one website. So it's a final website. It is called GrabCAD. GrabCAD is similar to ThinkIOS. GrabCAD. See here, what is a GrabCAD? It is similar to ThinkIOS. As we saw in ThinkIOS, they have a 3D model in a stereolithographic format. Here, you can download in a part file. It means part file means it's a file we can create using a Creo elements, or it may be a SolidWorks or CATIA. If you're going to draw a model, then you can save in a part file. Okay, you can download the part file, which is already available in this website. You have a gallery here, then you can download the parts which is already available. Okay, say for example, I'm having a 3D printing and a CAD collaborating. It is a software. Then you can search here. Okay, you can search community. You can search gears. And so now I am going to search for a gear. It is available. We will see. Okay, is it available or not? Standard, we have a parts which is available in a GrabCAD. You can download this file in part format. This PRT, full form is a part. You can download this and you can give it for 3D printing. Okay. Now we have a gear component. It's loading. Now it is a see here we're having a 3 CAD files of let's count. It's loading. Please wait. Yes. Yeah, we have a bevel gear. Guitar is different. Don't worry. This is a planetary gear. You can download. No need to draw. Okay, no need to draw. If you are not able to draw in a CAD software, simply leave it. It is not important. Okay, our aim is to learn robots, to build a robots. Okay, don't learn this type of software if you're feeling hard. Okay, if you're interested, then you may learn. Okay, now you can download the software in a form of part file, and you may give into 3D printing. Then you can attach this. Then you can join with the stepper motor and other things. Okay, so this is a purpose. Now I will give you the file. It is a PDF file. So in this session, I'm going to give you a PDF file. Please wait. Yeah, it is that webinar. Yes, we have a PDF file here. 3D models and other Arduino simulator DIY. As I told, it is DIY manual. It is specially made for you to learn from basics, to simulate the Arduino from basics. Here, I'm having the 10 exercises. You have to complete this 10 exercises. If you can able to, and you can give this 10 exercises, then you may able to do any simulations. Then see here, I will give you this DIY manual with your professors. I will share my file to your professors. Say for example, if you're having this step second exercise, we will see. Sure, sir, sure. I will send. Then next is here. It is specially made for you, professors and students. Yeah, here you're having a platform to Tinkercad. I'm having this QR code. Okay, this 10 exercises, this all 10 exercises, I'm having a clear video in my YouTube channel. If you're going to scan this QR code, then it will send automatically that video page. Okay, it will goes to my automatic page. Then you can see my video with a clear explanation. It is a step 8. Here I gave all videos and QR codes which is related to this. It is too much helpful for you and your projects. Sure, sir. I will send PPT. The next is there's a color coding. I gave clear explanation about this exercises, and I simulated. All this, and so on. It is recorded and it is uploaded in my channel. You can download it, and so now I am going to give one important thing. It is how to download a Tinkercad file. See, if you are a beginner, then you can. Right. You can download. Yes. Remove. Okay, no problem. Yeah, here you're having the circuits. No, see, it is a Tinkercad file. You can. If you are going to search, say for example, I am not going to give a circuit. So now simply I am a beginner. I am not going to give the circuit connection, and I don't know how to perform the codings and all. Simply search on internet. It is everything is available. Okay, including the coding, it is available for Arduino and robots also. Okay, simply I am going to search for ultrasonic sensor, ultrasonic. First to know how to search in Google. Okay, so it is very important. Okay, see, it is a simple trick, but you have to know. Ultrasonic sensor, Tinkercad file. First know how to search. It is a Tinkercad file. Go to Tinkercad file. Here in this, I gave the stepper motor and other things by manually. Okay, 3D design. They have a 3D design also. See here, they have a 3D design. If you are going to download, then you can download the stereolithography format file. Here I am going to give the circuit design, ultrasonic sensor file. Don't bother about the programs. It is already available, including the circuits. Okay, it is very simple. If you know how to download, if you know how to edit the programs, then surely you will be a good one, this Arduino. Now, here I have my ID. See, I'm not going to do anything with this ultrasonic sensor. I didn't give any connections. I didn't give any programs, but it's available. Give copy and tinker. So now this file is mine. Simply you can edit. Okay, by yourself, then you can simulate. If you don't know, if you are a beginner, then it is very useful. Then first know how to search in Google. Okay, don't go to other sites. Go to tinkercad.com files. So like this. Okay, then next is please wait. It is working. Is working. Please wait. Then you can download these files. Then you can simulate. Then you can copy the code to your project also. Okay, it is one important thing I'm going to do. Then there's loading. Loadings and other things are loading here. Then Okay. Tinkercad is not responding. Now, so please take a note. You can download the code and you can download the circuits also in this way. Okay. We'll wait. We have codes of ultrasonic sensors. Don't bother about codes. So now I didn't give any circuit connection. I didn't give any codes, anything. Here, this file is downloaded already. You can simulate. You can do this projects in real time also. Then it is very easy. It is very simple manner. You can download and you can give the connections. Then after that, you have to know the purpose, okay, of this ultrasonic center, this sensor and other things, simulation. Yeah, it's here. And now the system, see here, you can adjust the distance of this ultrasonic sensor. First of all, you have to know the basics of ultrasonic sensor. If I'm telling, that will be boring to you. Okay, so that's why I'm giving these instructions. It's like games. It's like a PUBG. Okay. Now, if you are going to cross this limit, okay, then this LED is going to off. If you are going to cross this region, then this LED will blink. Okay, so it is a purpose of this coding. Here they gave the coding like this. So it's the steps and it is the algorithm they gave here. Okay, simply you can download for all components. Search when you are free. Search this all components and circuits and edit it. And search when you are free. Search in Thinkrivers, GraphCAD, and on the website Instructables. Okay, so I hope you understood. So let us conclude. Is there any doubt? Is there any doubt? If the session is useful to you, thank you for this wonderful opportunity to the King's College of Engineering. Yeah, yes, sir. Yeah. Or Vaishali. Yeah, please. Or Vaishali Jaga PN. Elcott. Thank you very much for this session. Thank you very much for this opportunity. Now I will hand over the session to our Professor Venugopal sir. Thank you very much for giving this opportunity once again.
Thank you, sir.
Once again, I'm here. Thank you, Ganesh sir. I think this information, this online platform, would be a good knowledge to do robotic projects in this pandemic situation, right? Because we don't need to buy any other ultrasonic sensor, Arduino or anything, but you may do the projects in a good manner, right? Now I is my screen is visible, sir?
Yes, sir.
Yes, right. I think most of you have a doubt. If I am studying the robots in a passion way, if there is any way to get a job, right? Here comes the solution. Careers in the field of robotics, right? This is the scenario. That is, I get the source in Indeed.com, right? The average salary of a robotic engineer. Did you get the point? The robotic engineer, for a CAD designer engineer, mechanical engineer, for a robotic engineer, $100,000 per year, right? Especially in India, you can get a salary of 3 to 4 lakhs per year at the starting stage. This could be a better choice if you are passionate to do robotics. That's the thing. If you are passionate, then only the robotics will help you a lot. Not like a job; it's a career, right? Right. The job titles are robotic programmer, robotics technician, robot design engineers. These are all the robotic-based career jobs, right? And then some top recruiters. We already know DRDO and ISRO are most hiring researchers in the field of robotics because in our Indian Army we have unmanned aerial vehicles and we have drones, but we purchase components from China. as I already know, even a small BLDC motor or any controller for your drone, we have to purchase from a Banggood or a Amazon or any product that is made from China itself, right? But this situation, this pandemic situation, government of India producing lot of funds to the new researchers, and this could be the good platform to initiate a new robotic industries or robotic based limited companies, right? These are all the company they are hiring robotic based jobs. And then few companies which are started in the past 20 years, and especially the Inventor Robotics, right? So they created a Mitra, responding robots. Responding robot in a restaurant or in a very specific places, they use this Mitra robots. And another one, the Sastra Robotics. It's a entrepreneur company. That's a startup company. Now they are dealing with Boston Dynamics. That is a Europe-based company. They have to build one technology with the ROS, robotic operating system. They export that system to the Europe. Likewise, they build up a lot, and the company CEOs are very young age. Even they didn't get the age of 30, 32 itself. They have an senior, they have a career which having senior robotic software engineer. They need senior robotic software engineer, and these are all the requirements. They need C++ and Python coding. And then each senior robotic software engineer needs C++, Python coding, and the knowledge of GNU Linux, especially good knowledge in ROS. This could be the good platform if you are a basic learner in ROS, then you are the expert. From this situation, you are the expert in this. As ROS is basic for artificial intelligence, incorporating the artificial intelligence in your robot, this could be the best choice. Right. What type of person works in robotics? This is a very key factors. If you are stick to any one discipline, please don't take off the robotics, because the robotics needs the basic knowledge of all the disciplines, right? So you have to go through with mechanical aspects. If you do your projects, you don't need to say this is electrical. I don't know. I will switch over to another one. This is mechanical. I don't know. You won't say like this, right? In your project team, you must know all these aspects, right? So that's the robotics plays a key role in all the disciplines. A roboticist, essential skills needed for a robotist. These 10 essential skills. The first is the system thinking, right? You have to frame the work. What are the process that you have to give to the robotics? You have to frame first thing, right? If you have to take any video or something, you have to write the script. So then only you have to identify what we are going to do. So likewise, you have to think like a system, right? How it is perform, how it is going to rectify the problems, likewise, right? And then you have to set your mind for the programming, which type of programming you have to going to use. Whether it may be ROS or maybe some other platform, or you may use some other boards. You have to hire some boards. So you have to set the mind, right? And then you should be an active learner, right? Every year or every 2 years or 3 years, the robotic platform may change. The ROS version from A to M. In the past 10 years, the alphabetical order, it started with alpha, right? ROS alpha started with alpha. Now they comes under K, kinetic, lunar, and then here comes the melody section. And now they switch over to ROS 2, right? So you keep on learning, then only it helps you a lot, right? As I said, mathematics is a basic. So you should know the basic factors, that is trigonometry, statistics, it's all basics. Then sciences or applied mathematics, because if you have to design a rover in lunar, there's a moon, so you have to know what type of gravitational force and what type of sand, you have to think about it, you have to know the basic science. Then decision making, if you are a robotist, you must take the decision, don't give the decision to the others. Then everything, you should have a good communication skill, right? And then technology design, don't stick to the old design, you have to search all these aspects. Now the HD camera comes over, then for image processing and the thermal imaging camera, night vision cameras, then laser guidance missile system, the technology keep on changing, you have to update yourself, right? And then you have to incorporate the complex problem solving, right? It's very basics. If you have to design the artificial intelligence based robots, you have to think about this complex problem solving, right? First you have to think, then only you teach the robot to think, right? Last is the persistence, right? These are the basic skills needed for a robotist, right? And as a part, we started RC club in our college in the last year, July. And from the 1 year of all the teamwork, finally we designed one robot that is an unmanned aerial vehicle. This is the God's Eye model, which is selected in SIH 2020. It's now going on. We are in the final team, finalist contestant of SIH 2020. And we created a unique design of UAV for surveillance, right? This design is not anywhere in the world. It's like a dragonfly design. We have changes the anatomy of the, we have segregated, we have incorporated the dragonfly anatomy, that is nature's anatomy, into a project, right? It will help you a lot because technology is based upon the nature evolution, right? The train, aeroplane comes because of the butterflies or anything, right? So technology transfer based upon the nature. So we created the idea from the nature. So if you have to find out a solution solution for a problem, you have to think the problem in a natural way. That's the thing, right? And for a hobby and entertainment, the world robotic competition, we are going to participate in the fastest line following robot. Not a line follower, it's the fastest line following robot for the Technocian 2020 competition, right? Right. We are encouraging the students to work with RC flight gliders and drones, right? My team students, it is all are from various departments, and then they design their own flight. We are not stick to the plan like designing an individual flight. We are giving some ideas to the students. Students have to evaluate and design something. Then we have to guide and mentoring the students to design like this, right? How to use a rudder, how many blade propellers are used, what the type of the motor. We have to guide the students, right? From this guidance in the past 1 years, our students goes to IIT Bombay, IIT Chennai for Boeing IIT contest. And later one project is selected in SIH competition. I will play the video of Sir, is it visible, sir?
Yes, sir.
Anybody is it visible? Yes, right. Thank you. And this plate is designed by the girl students. The same unique design is applied in IIT Boeing contest in Chennai. Right. This is our scenario, and we got a wonderful opportunity to do this in our college. I think if you are a good passion to do some more projects, you have to work it out. Then only it will help you a lot, right? One thing I have to tell you, in any design of projects, right? In any design of project, either it may be a small project or a robotic project or a normal project. If you have to design or you have to think and innovative, you must think this golden ratio. Everybody knows about it, but I have to repeat, because if you do projects based on measuring items like in the golden ratio, project is superb. In the SIH competition, we designed so many robots. Example like this flight, right? In the SIH competition robot, there's a flight. We take the dragonfly anatomy um, and we use this golden ratio. The golden ratio is 1:1.618. For example, if we have a hand, if it is 1, it should be 1.618. If in the face is 1.618. Everything is golden ratio, right? If you have to design, use this golden ratio. Think about it. Remember this golden ratio. It will help a lot. Like this, 1:1.618. If it is 1, then it is 1.618. Like the golden ratio, here comes the golden spiral, right? You can imagine our temples, especially Tanjavur big temples, Madurai temples, and every temples are designed based upon this Fibonacci series. But it was invented by Fibonacci in 1400. But we are the Tamilans. We designed this, we created this Pingala number in nearly 2000 years back. Then these are the aspects. They created this spiral, golden spiral in face surgery or rechange, anything. These are all from the nature part, right? And for the golden angle, that is 137.5 degree. So it is a golden angle. If you think of this plant, it is not like this. It's growth like this. When you see from the top view, it should be that golden angle. So each plant grow in a golden angle, right? So science is a wonderful thing. If one does not have to earn, one's living at it, as Albert Einstein. And the last quote: whenever your passion becomes your profession, your life is beautiful. I am living in that way, right? If your career is your passion, then you get a wonderful life, right? Thank you for the opportunity. Think. Any clarification?
Thank you, sir.
That's all my side. If you have any queries, you can post it down, right?
Okay.
That's my mail ID. I given that mail ID, you can post it down.
Participants can offer their feedback at the end of the session. Queries are asked in the chat box. Venu, sir,
Yes, sir.
there are some queries in the chat box.
Just wait, sir. Is my screen is visible, sir? I have to switch.
Your desktop is visible.
Yes. Very useful. Anything application of robotics in IT industry? Somebody asked regarding the IT industry, right? Nowadays, IT industry don't need any robotic operation, but in programming, we are utilizing this industry, right? We use the ROS software. In ROS software, most of things depends upon the IT industry, right? Any other? I think Sar explains the Tinkercad, right? If you are a basic, I tell about the 3 stages, level 1, 2, 3. In level 1, you should be in there. You have to think about the micro controllers, that is Arduino or anything. This pandemic situation, this online software Tinkercad will help you a lot. Without using the hardware, you can program anything. You can, by using Tinkercad, this version, it is in circuit mode. If you design a model, Tinkercad model, you can design your robot diagram, right? You can design your robot car. And then you can incorporate the controller, Arduino controller in that board. You can use that one in a similar way, right? It should be helpful in this pandemic situation. Thank you. Very useful section. A question and answer section. Any feedback form is available, sir. Feedback link.
Participants, you can ask if you have any queries.
You can type, I will run. Can you guide us for doing final year project? Sure, but we are mentoring, not to do projects, right? In our college, we mentoring the students, not to do their projects, right? We help you a lot. Even 24/7, we are running. Still now we have 3 meetings is there. One for SIH, one for TI, that is a DST and TI. Our Vedics team, Vedics product is there. And then Smart Gym Shoot. One project is going there. And then Agni Missile 6. We are planning to incorporate, that is, we have planning to formulate the Agni missile, what type of is going in there. So we have some meetings. We help you a lot, right? But we guide you. We don't give any information. We facilitate you, right? That's sure about this, because some students are misusing there. That's why we are using. If you are really interested, we help you a lot, right? Can you explain about robotics and in the field of biomedical engineering? Yes, definitely biomedics have a boom of robotic application, right? Even for a plasma cell therapy, they use the robotics, right? And in the in the medical field, Da Vinci robot, it's a first robot that is used for surgery from a remote location, right? Likewise, so many robotic applications related to biomedicals. Useful ECE students for robotics, definitely, because one of the 4 team, that is 4 pillars of robotics is, one is mathematics, second one is the electronics, right? Third one is the mechanics, and is for the computer science and for programming. So ECE plays an important role in order to design a power backup. You triple guys also needed. How IoT is useful for everything? Everything is IoT, man. Everything is IoT. Now it turns a lot. You can control your bot using Wi-Fi. It comes under IoT. Right. You can use your mobile phone to control your home automation. Everything is IoT. Without IoT, you won't live. Anything else? Difference between Proteus and this Tinkercad software. Please explain, sir. In Proteus, we are designing a PCB. Here, this is not a PCB. Here is an online tool to simulate the hardware, right? And then you may use blocks to design your dimension or car appearances, and then you can incorporate the circuit board into the car, and then you can simulate that in a like a robot, right? For a real robot, real hardware application, you may first think of this Tinkercad. You can work it out. If it is good, you can design your outer part design of your robot. Then you can implement everything in your real-time application. But it is somewhat different from Proteus. Proteus for PLC, it is PCB fabrication, PCB like process. Software is free of cost. Of course, it is free of cost. You will receive EM for this. I don't know what's EM certificate. It comes under your part. What is the use of 3D print? Right. If you are designing your bot, you can design your robot in steel, right? Right. If you have to design your steel, you have to molding process, some other mechanical process is there. If you create it in Tinkercad, you can print it in 3D, right? And you can assemble it, right? It will be helpful, very helpful. Yes, we will send the PPT and manual to you. I will send the document to Niranjan sir. YouTube channel name. Ganesh sir gave the name. If you scan that QR code in the manual, he will send that manual. You can send the code, it will directly go to the YouTube channel. Right, I think wonderful purpose of 3D clarity. I think biomedical, computer science. In the field of computer science, I already said computer science is one of the pillar for robotics and for programming ROS or anything, right? Ubuntu OS or a C, C++, Python coding, everything is there. Computer is one of the pillar for robotics. So for a robotic team, you must have a presenter for any project team. So we segregated the teams, right? We pick up in the last year or a few years back, we created a team. We just go into the class and ask some students, if you are interested in project, come over to the project lab. Now we are planning to create a team which has a hardware person, and a presenter in the team, 2 programmer in the team, right? If it is 2 presenter, 2 programmer, 1 hardware, so then the team should be a team, right? He can satisfy any constraints, easily achieve any local competitions or higher level competition. So we are in move up as a part of EC department. In our college, we have an innovative contest. Last 5 years, we won the innovative project ideas and innovative competitive departments. Right. The team building is very important. Better be alone than in a bad company, because you have to work a lot. Others simply sit and getting the prizes. I think satisfy what field Python is used for robotic programming. Yes, for Raspberry Pi we need the Python programming and some other softwares. Nowadays Python is basic for our engineering subject, right? So it's play a vital role. Driving car. No need of any instructor to guide it. Yes, already gave the answers. No, a self-driving car can be driven by a driver. It works on self-driving in the absence of driver. But only C, C++ is used. Not like that, we can use a code block also. Ganesh has said that code block, you can utilize that well. If you are a beginner, you can use the code block. If you are interested in coding, you can go to C or C++. I interested in doing projects, but I don't have any idea where I can get it. Right, I will tell the reason. The first thing for getting an idea, don't search Google, right? Google says someone idea, right? Real fact, you can search idea from your home or agriculture field or anything, right? You can search in your own, right? If you think of you have to get idea, you can get it. Don't search Google. When you get an idea, then only you go to search the Google for what type of test, what it had been done or not. You have to search like this, right? Don't search idea in Google because it already done by somebody. Please select your field to do projects. Somebody ask about projects. Where do I start? Please select your field for your project. You can search DRDO. They have an opportunity to go on internship. Search in the DRDO. Internships are available, but you have to prove you are doing some work in that area. Then only they give the internship. Our King's College is having a funding of 1 crore rupees in the laser communication system. Right. You can ask that Niranjan sir. Very long, big, similar to C++, how it is possible use Arduino using Python. Yes, it is possible, but still works going on. Still works going on. Yes, it is possible. Or another higher level programming language. In fact, platforms like Arduino works well with Python, especially for applications that request integrated with sensors, other physical activation. Yes, Python plays an important role nowadays and utilize it well. Application that requires integration. Apart from Python ROS, any other stuff required for a beginner. If you are well in ROS, you don't need you are not a beginner, right? ROS somewhat differ. You can, if you have to install the ROS, you have to go through at least 3 or 4 days to installation process, right? Golden ratio, golden angle, yes. Every section I handling. In fact, every classes I discuss one social aspects, right? That comes on this golden ratio. It's very useful. Implement in your daily life. It's very useful. And then one course called Fibonacci series and golden ratio in Coursera. It's a free course you can attend. They give a lot of information about the golden ratio. We can see the way, if you are studying golden ratio, you can see the world in the angle. Some app is there, like a golden camera is there. You can download and you can see. Very helpful. Thank you. Tinkercad, GrabCAD, Thinkiverse, Instructable. These are very useful websites. Right. Not like that. No, don't stick to Arduino board. Arduino is a development board. It works good, but it is a development board. If you are doing a project, it's work good. You have to convert that project into a product. So you have to replace that IC, Atmega 328 IC in some other boards, or you may use some PCB, and then you have to implement, you have to design your own boards, right? It will be helpful. Then it should be a good hardware. You should be a good engineer. We are using now 8th standard or 5th standard students using Arduino, right? Even college nearer school is there, PMG school, they use Raspberry 5 for a 5th standard project, robotic project. And any other? And this is Rajesh, APCSC King's College. Thank you, sir. So Niranjan sir, I think
Yes, sir.
I answered all the queries
Yes, sir.
to me. If there is any queries, please chat or can mail me. I will contact you.
Thank you very much, sir.
Thank you, sir.
It's my privilege to have been asked to propose a vote of thanks on this occasion. I, on behalf of R&D section, extend a very hearty vote of thanks to the honorable delegates who are present here. I must mention a deep sense of appreciation for their valuable lecture to Mr. E. Venugopal, Assistant Professor, Tribly, Sri Ishwar College of Engineering, and Dr. S. Ganesh Kumar, Assistant Professor Mechanical, for sharing their experience and their work. The way their content was delivered was exemplary. I also wish to express my gratitude and thanks to our Secretary Sir, Dr. R. Rajendran Sir, and Principal Madam, Dr. R. J. Arpuda Vijayaselvi Madam, for their constant support and encouragement. I heartily thank all the participants for their active participation in this event, as no program can become successful with a single person. So I extend my big thanks to our DRC members for their support. Thank you for making this event successful. Thank you, one and all.
Thank you, sir. Thank you, participants. I hope this section would be helpful to do some ideas in online tool and also for your career. Thank you.
Feedback link is posted in the chat box. It will be open till 1 p.m. Thank you.
Thank you, sir.
Thank you, sir.
Thank you, sir.